Good. Yeah. All right. So, tell you later. So, in this one, it's already changed to sine and cos. So, remember, and I'll re-highlight them on here. So, on our strategies, our go-to strategies were these two, right? Change to sine and cos and get things to be a single fraction. Those are our go-to strategies. And in this one that we're just about to do, it's already done. Things are sine and cos, and they're both already a single fraction. So when you get to this point in a proof, and sometimes it happens halfway through the proof, this is just a great example that it happens right away. At this point, you get stuck. You're like, I've done my main strategy of changing to sine and cos and getting to a single fraction, and they're not the same. So when that happens, we have two main strategies to use when you get stuck. I'll highlight this one and this one. You are either going to try to factor, aka if you have a difference of squares, or you are going to the other side. And this example is the one where we're going to use this last one, which is build the other side. So we're going to go back to it, and what it means to build the other side is if you've got a single fraction and they're not the same, why don't we try to at least get the denominators the same and then see what happens. So if I want both the left-hand side and the right-hand side to have the same denominator, well, this one's missing sine, so I'm going to multiply by sine over sine. This one's missing 1 plus cos theta. And on first glance, this appears to be that you're making the question more difficult looking, which is kind of true because you're adding something to it. You're making it a little bit less simplified. But at least now, and I'm not even going to multiply out the bottom, I'm just going to leave it factored. Sine theta times 1 plus cos theta, at least our denominators are going to be the same on the left side and the right side. Now when I multiply on the right side, I'm going to get sine squared theta. And maybe you notice at the top of the left side, a 1 plus cos theta, 1 minus cos theta, that's a difference of squares. The fancy word for when you have binomials that are the same things with a different sign in between is called the conjugate. So 1 plus cos theta and 1 minus cos theta are conjugates. And when you multiply two conjugates, you get your difference of squares, and so 1 minus cos squared. So now we've succeeded in at least getting the denominators the same. And now you can look at the tops and say, is there any way I can change things to get my numerators the same? Yes. 1 minus cos squared is sine squared, and we are done. Nice. So this is a good example of where the build the other side strategy comes in. Now if you look on the worksheet that we had, there's a couple of places where the build the other side strategy comes into a place, and there's a couple of shortcuts to be able to see where in particular it would be really helpful to use. For example, in this one, if I just erase what I have up here. Now, you know that you're not allowed to work from one side to the other. But if you look at a question, and if you were to cross multiply right at the beginning, multiply along the diagonals, do you see that you would get the 1 minus cos squared and the sine squared? If you get one of your three Pythagorean identities right away when you cross multiply, you can use the build the other side strategy to quickly solve it. So on your, if you have this identity sheet handy, look at number 29. Here, I'll just, for those of you that don't have it, 29 you were asked to prove this. Can you see that if you would multiply across like that, you have tan squared on one side and secant squared minus 1 on the other side? And if you have that memorized as one of your Pythagorean identities, then that's telling you that the fastest way to do this proof is to build the other side. If you change this one to sine and cos, I don't know, has anyone done this and changed it to sine and cos? If you simplify it, I believe you get this proof at the end, and it still doesn't work. You still have to build the other side. So if you built the other side right from the beginning on that one, it would go a lot faster. Part B. So looking at a question like this, I see that I have cosecant squared. So I have an option. I could change cosecant squared to cotangent squared plus 1. As sort of a general rule of doing lots and lots of proofs, you normally don't try to make it bigger. So changing cosecant squared to cotangent squared plus 1 would make it bigger. Generally, you don't, that makes things more complicated. So I'm going to hold off on that. But I'm going to look at that and think, okay, that's an option. Maybe if things go bad, I will start again and try that as my first option. But looking at this question, the left side has cos in it. The right side has cosecant. Maybe I'll try the basic strategy, change things to sine and cos, and see where things go. Now, with 2 cosecant squared, here's your question. I know that cosecant is 1 over sine. So is 2 cosecant squared, is it 1 over 2 sine squared theta, or is it 2 over sine squared theta? Okay? I want you to think about that. I want you to make a mathematical decision in your head what makes the most sense for you, because one of them is right and one of them isn't.
Because it's 2 times cosecant.
It is 2 times cosecant squared. So if I put a little green dot in there to say 2 times cosecant squared, if before I get to one of these, if I think, well, that means it's 2 times 1 over sine squared. How do you multiply something by 2? Because this would be 2 over 1. So yes, it is just 2 over sine squared. The 2 does not move down with the sine. Cosecant is 1 over sine squared, but that 2 out in front would stay multiplied, which would make it stay on the top. Okay, so I've got a single fraction on the left-hand side. On the right-hand side, I don't. So how do we get a single fraction? We need to get common denominator. So this one really looks messy to begin with, because here I have to multiply by 1 plus cos theta and 1 plus cos theta. And here I would need to multiply by 1 minus cos theta over 1 minus cos theta. We see the conjugate again on the bottom. So our common denominator is going to be 1 minus cos squared. And on the top, we'll get 1 plus cos theta plus 1 minus cos theta, which will just be 2. So now we've got a single fraction on both sides. They don't match, but the only thing that's not matching is your denominators. What can you change 1 minus cos squared to?
Sorry for interrupting.
Hello.
I had a calculator drop.
And so left side is equal to the right side, QED. Pew, pew, pew. All done. All right, the ones for practice, just 12A.